Lesson 4, more volumes. Question 1 says a cylindrical container having an inside diameter of 60. So I drew that first cylinder. Diameter of 60, height of h is filled with water. So the whole thing's filled up. What is the number of cylinders with inside diameter of 10? So that's going to be a smaller cylinder. So I drew one. Doesn't matter that they're not to scale. Also height h. So how many small cylinders is it going to take to equal the amount of water in the first cylinder? So this is all to do with volume. So we know that the volume of a cylinder is equal to pi r squared times the height. So because the heights are the same for both of these cylinders, all we're going to worry about is the radiuses. So for the first cylinder, we know the diameter is 60. That means my first radius is 60 divided by 2, or 30. And my second radius is 10 divided by 2, or 5. So I'm going to use those when I'm doing my work. So volume 1 is going to be pi times R1. R1 was 30, so 30 squared times h. So that's going to be pi times 900 times h. Volume 2 is going to be pi times 5 squared times h. So that's going to be pi times 25 divided by h. And they want to figure out how many volume 2s fit into volume 1 or divide into volume 1. So V1 divided by V2 is going to give us the number of small cylinders, I'm just going to put cylinders, that fit into the big cylinder. So volume 1 would be pi times 900 times h. Volume 2 is going to be pi times 25 times h, and a whole bunch of stuff cancels out. So pi cancels with pi, h cancels with h, and when we simplify this all the way down, we get V1 over V2 equals 900 divided by 25, or 36. So our final answer would be 36 small cylinders would be required to hold the same volume. And if I wrote that out, therefore need 36 small cylinders to hold the same volume of water. Question 2. A rectangular box has edges in the ratio of 2 to 3 to 4. Total surface area, okay, that looks useful. Edges in the ratio of 2 to 3 to 4. If the total surface area of the box is 100, so surface area is 1,300 centimeters, find the volume. So they're asking us to find the volume of this box. And they gave us a hint that we should call the edges, this goes back to that ratio, 2K, 3K, and 4K. So that's going to be like a scaling factor. So I'm going to call the edges 2K, 3K, and 4K. And if we were going to find the surface area of this box, so the surface area of the box, it would be that we find, I'm going to label my top, I'm going to say side A, the sort of front facingness I'm going to say is B, and that one I'm going to say is C. So the surface area would be, I'd have 2 A's plus 2 B's plus 2 C's. I'd have the top and the bottom, those are the A's, the front and the back, those are the B's, and then the 2 sides are going to be the C's. So we know that that would be 2 times the volume of A, well, that's 4K down there, so it's going to be 4K here and 3K there. It's going to be 4K times 3K. B is going to be 2K times 4K. And C is going to be 2K times 3K. So I get 2 times 4k times 3k, so number times number is 12. K times k is k squared. So that's 24k squared plus 2 times 4 is 8. Letter times letter, k squared. So plus 16k squared plus 2. 2 times 3 is 6. K times k is k squared. So 2 times 6k is 12k squared. And when we add that all together, we get 52k squared. And if we look back at the question, it told us that the surface area was equal to 1,300 square centimeters. So that's that surface area. That's what we just figured out the whole thing. So 1,300 equals 52k squared. To get k by itself, I'm going to divide both sides by 52. So divide by 52. And then we get 25, which is convenient, because if 25 is k squared, square root both sides, I get that 5 equals k. So we've solved for the scaling factor. So that means for the box that instead of k, if k equals 5, 4 times 5, so it's going to be 20 centimeters. Oh yeah, because this was all in centimeters. And that's going to be 3 times 5, which is 15 centimeters. And then the height is going to be 2 times 5, which is 10 centimeters. So we can finish off by answering now for the volume, because they wanted the volume of the box. So that's what we were going for. So the volume is going to equal, normally it's length times width times height. So in this case, it's going to be 20 times 15 times 10. And when we multiply that all together, we get 3,000, and it's going to be for units centimeters cubed. So the volume of the box is 3,000 centimeters cubed. Question 3. A plane cuts a block, and by plane they do not mean an airplane. When they talk about a plane here, it's like taking a piece of paper. It's like a sheet, a flat two-dimensional sheet. So it's like this whole thing is like you're cutting the block, cut with a flat knife. Okay, so a plane cuts a block through the midpoints of the 3 edges is marked. So through those 3 dots. The smaller piece is then discarded. And it asks, what is the volume of the remaining part of the block? So in this case, we're going to need to find the volume of, well, there's a lot of ways to do it. One way to do it would be to find the volume of this triangular prism. So let's do that. The volume of the triangular prism is going to be that area of the triangle. So base times height divided by 2 times how long, if you could see my hands, I would be extruding them, how tall up that triangle got stretched. So base times height over 2 times the length. And for the triangle, if it was 4 all the way across, then that's going to be 2. Its base is going to be 2. The height of the triangle is also going to be 2. So 2 times 2, cut in half, times the length of 6. And that's going to be 4 over 2, which is 2 times 6. So that's going to be 12. The volume of the rectangular prism is 12 centimeters cubed. And then if we were going to figure out the volume of the entire block and then subtract away the triangle, so the volume of the regular block is just going to be length times width times height, which is 4 times 4 times 6, which is 96 centimeters cubed. If we were doing it, taking the total, so it says what remains, so V remain would equal V block minus V of the prism. So that'd be 96 take away 12 And 96 take away 12 is 84 centimeters cubed. So that's one way that we could solve it. And that way felt long. The way that I first thought of doing it is if we looked at this from the top, it'd be like we were taking away that pink triangle. I hope here, I'm gonna put green all around it. So if you're looking at this top view, if we were to cut away that pink triangle, remembering that that was in the midpoint of everything. If I draw a whole bunch of these other green lines, I hope you can see that that pink triangle would end up being the same as 1/8. 1/8 of the whole thing. So if we cut off that pink triangular prism, that'd be like take away 1/8. And that would mean that the V remains would be 7/8. So everything that would be left, V remains equals 7/8 of the total, or of the block. And interestingly enough, if you do 7/8 times 96, you also get 84 centimeters cubed. So that's two different ways of doing that problem. Question 4. 3 tennis balls are tightly packed in a can. What fraction? So fraction right away is making me think I'm going to be dividing. What fraction of the volume of the can is occupied by the tennis balls? So we're going to have to figure out the volume taken up by the tennis balls, the volume taken up by the can, and then figuring out what that fraction is. So I've drawn three spheres, and when you're drawing spheres in 2D, you can just draw a circle. So 3 spheres, and if the radius of one of the tennis balls is r, that means that the height of that tennis ball is going to be 2r. And if I have 3 tennis balls, each with a radius of 2r, that means that the height of my cylinder is going to be 6r. And we'll use that when we figure some stuff out. So the volume of the can is going to be pi r squared times how long it is, right? Or how high it is. So in this case, it's going to be pi times r squared times 6r. And if we pull the number out front, so 6 pi and then r squared times r, that's going to give me r cubed, so that the volume of the can is 6 pi r cubed. Now we're going to figure out the volume of 3 spheres. So let's figure out the volume of one sphere and then times it by 3. So the volume of a sphere is equal to 4/3 pi r cubed. But because we have 3 tennis balls, 3 times this is going to equal 3 times that. And the reason why I'm doing it this way is because when I multiply these fractions, because 3 is just over an invisible 1, the 3's will cancel. And so the volume of 3 spheres is going to equal 4 pi r cubed. And they asked us for the fraction. What fraction of the volume of the can is occupied by tennis balls? So this fraction they're asking for is going to equal the V of 3 spheres divided by the volume of the can. So 3 spheres we got was 4 pi r cubed. The can was 6 pi r cubed. And very nicely, again, things cancel. So pi with pi, r cubed with r cubed. So we get 4/6, which simplifies to 2/3. So therefore, the fraction of the volume of the can occupied by tennis balls is 2/3. And you can figure out what that therefore would be. Question 5. So yes, I pre-wrote and drew a bunch of stuff here. Question 5 said a rectangular box has edges 3, 4, and 12. So I drew that there. And then it wants us to calculate the length of its diagonal. the diagonal of the box goes from one corner all the way through to the other. So that's the one that I drew in green. And said, hint, draw the diagram. Then I used Pythagorean theorem in two triangles. Okay, so we're going to do that. But because I've done a question like this before, I knew that to find the diagonal, first I needed to find the diagonal of the side face, so the one that I did in pink. So first I need to figure out what that diagonal is. And so I drew a side view. If we were looking on the side of the box, it's so much easier to show this with an actual box, but if we were looking at the side of the box, it would look like this if we flattened it out. And so all we have to do right now is calculate what C is. So C squared is going to equal 3 squared plus 4 squared. So that's 9 plus 16. So C squared equals 25. Square root both sides. I get that C equals 5. So we now know that that pink diagonal is equal to 5. Okay. But we want the green diagonal. And the green diagonal, you have to kind of think about it in 3D. It might be a little bit tricky. It's going to be this triangle. And again, I've drawn it not inside the box, over here. So that triangle has one length 5, another edge 12, and then we're going to solve for that diagonal D. So we would have D squared equals 5 squared plus 12 squared. So that's 25 plus 144. So D squared equals 169. Square root both sides. We get that the diagonal is 13, and there were no units given. So I'm just going to write that the diagonal is equal to 13 units. And that's the answer. For question 6. This one also is very useful if you had a diagram. And if you want to make it yourself out of paper, I would make a half circle. And then I cut that out of a piece of paper and then fold it around itself so it makes like an ice cream cone. I've tried to draw it for us. A paper cone, when cut along its slant height, so the slant height is this part here. So if we cut it along there, that actually ends up being the radius of the semicircle. And so it's totally not drawn to scale. And this is where if you made your own model, it would probably help a lot. So that's first one thing. The slant height here equals the radius of this one there. And the other thing to notice is that the circumference of the cone is equal to the semi-circumference, like the circumference of that half circle. Those two are equal as well. So a couple of things. We can easily, we don't know anything about the cone, but we do know from picture 2 that the semicircle has a radius of 10. So if the semicircle has a radius of 10, that means that the slant height is also going to equal 10 centimeters. So that's the first thing we know. Second thing we know is that this semi-circumference, I'm going to call it C2, it's going to equal, normally a circumference is equal to 2 pi r. But in this case, it's only for half a circle, so it's going to be divided by 2. So that yellow line, circumference 2, is going to equal 2 times pi times 10, so that's 20 pi over 2. So I get that C2 is equal to 10 times pi. I'm keeping all the pi's because eventually they cancel out. That semi-circumference of the semicircle means that the circumference of this one is also equal to 10 pi. I'm going to highlight that in pink. So the circumference of our cone base circle is 10, and we're going to work backwards to figure out what the radius of the base of our cone is. So we know that circumference usually equals 2 pi r. our circumference is 10 pi. So 10 pi equals 2 pi r. I want r by itself, so I'm going to divide both sides by 2 pi. And this is where all those pi's cancel out. Like I said, they would. So pi's cancel. 10 divided by 2 is 5. So we get that the radius of our cone is equal to 5 centimeters. So the radius of the cone is equal to 5. And then we're almost done because they want us to find, all of this is to find, if we go back to the question, it said find the height of the cone. So if we're gonna, I'm running out of colors, find the height of the cone, I'm gonna use very brown for the height of the cone. So now to find the height of the cone, we have a triangle that's got, that's got height h, radius of 5, slant height of 10. So we know that h squared plus 5 squared equals 10 squared. H squared plus 25 equals 100. H squared equals 100 minus 25, which is 75. If I square root both sides, if you were going to do it on your calculator, you would get square root of 75. Well, my calculator, because it knew to pull out the 25, the perfect square, because it knew it was 25 root 3, 5 root 3, that's one answer, and it matches what's given right here, which is nice. But the other way you could have done it is just straight up on your calculator, and 5 root 3 equals 8.66 centimeters. So either one of those would work for your answer to the height of the cone. Thanks for watching.